Hey guys, so today we're going to be talking about the Pythagorean theorem. So for those of you who don't know what that is, I'm going to write the equation for it real quick. It's going to be a squared plus b squared equals c squared. Now you may be wondering what that means and what it applies to, and that's what we're going to look at right now.
All right, so now let's kind of work through this whole a squared plus b squared equals c squared nonsense. All right, so where it says definition, let's go ahead and write in given three side lengths, they form a right triangle if the square of the first leg, a, plus the square of the second leg, b, equals the square of the hypotenuse, c. Now, you may have written that and heard me say it, but let's kind of work through it and see what it actually means, because there's a lot to unpack here. So, given three side lengths, okay, that refers to the three side lengths of a triangle. In this case, we're talking about a right triangle. So that's the next part. They form a right triangle, which is any triangle that has a right angle, a 90-degree angle right here. They form a right triangle if the square of the first leg, A, now let's walk through that a little bit. There are three labels here, A, B, and C, and they are labeling each side of the triangle. Let's first talk about A and B because they are both called legs, all right? So A and B are called legs, and they form the right angle. Okay, so here's A, here's B. These are called the legs of the right triangle, and they form the right angle. So the corner that they meet at, that is our 90-degree angle. Okay, so we'll go ahead and fill that in. All right. Okay, and it says the square of the first leg A. Okay, and what that means is there's a square that you can build from the side length A. All right, so I'm going to show you what that looks like really quickly. So that would be this one. Okay, so I have now taken the side length A and made it into a square here. And you should see that on your diagram. That's where this comes from, okay? So the square of the first leg A, that's right here. This is A squared, plus the square of the second leg B. Okay, so let's go ahead and put in our b square. So there it is. I've now formed a square with b down here. All right. The square of the second leg b equals the square of the hypotenuse c. So before we put our last square in here, let's talk about c because it's special. All right. C has its own special name called the hypotenuse. Okay, so C is called the hypotenuse, and it's always across from the right angle. So we have our right angle here, okay, and then across from that is C, which is the hypotenuse. That's the name of it. This is also the longest side length. It will always be the longest side length. Okay, so C is called the hypotenuse. It's always across from the right angle. Let's go ahead and build our last square here. And as you can tell, it's also the biggest square. You can kind of visualize that. So one last time, let's walk through the definitions so that we can put all this together. Given three side lengths, they form a right triangle, this right triangle right here, ABC. If the square of the first leg, A, so that's this orange square, plus, so this is adding, the square of the second leg, B, so this is the pink square. If you add the area of this square and the area of this square, it says it equals the square of the hypotenuse, C, this area right here, okay? So if you can kind of see the grid lines in here. If you actually count this up, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 squares inside here. Okay. So we've got 9 in here. And then if we count this up, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. 16 squares inside here, which means the area of this is 9 and the area of this is 16. What the Pythagorean theorem says is that this 9 plus this 16 will tell you how much is in here. Now, if you're playing along at home, 9 plus 16 is going to give you 25. Okay, so the area of this blue square is 25. All right, that is where a squared plus b squared equals c squared comes from. Now, let's take a look at a few examples of how you're going to apply this knowledge.
All right, so now that we've got a better understanding of what the actual Pythagorean theorem is, let's take a look at how it'll apply in some of your practice problems. So I'm just going to give a couple examples of what that may look like. You'll be given 3 side lengths. So we're going to start with 3, 4, and 5. Okay, so you'll be given 3 side lengths like 3, 4, and 5, and then be asked to determine whether those 3 side lengths can form a right triangle. And the easiest test for that is the Pythagorean theorem. So first thing you'll want to do is assign A, B, and C to your 3 side lengths. Now, C is the one that matters the most, so let's start with that. C represents our hypotenuse, which is what we just talked about, which is always going to be the longest side of the triangle. So, in this case, since 5 is the biggest number, we're going to call that C. And then just for convenience sake, we're going to call 3A and 4B. So that's just ABC, just like that, all right? Now, what you do is you plug in 3, 4, and 5 for A, B, and C in the Pythagorean theorem. So since it starts with A squared, we're going to write 3 squared. All right? And then plus B squared, which in this case is 4, so 4 squared, equals C squared, which is 5 squared. All right, so now basically you're just trying to decide whether this makes sense, whether this is true. So you can either type this in your calculator, or if you're comfortable with squares, we'll just do it that way. We've got 3 squared, which is 9, 4 squared, which is 16, and 5 squared, which is 25. And then over here we've got 9 plus 16, which is 25, equals 25. Which means this works. If you end up with a true statement, 25 does equal 25, then you know that 3, 4, and 5 do in fact form a right triangle. Just like that. All right, so let's take a look at another 3 side lengths. We're going to do 4, 5, and 7. So again, the first step you want to do is figure out what your A, B, and C are going to be. Let's start with C again. We know that C is going to be our longest side, so we look 4, 5, and 7. 7's the biggest, so we're going to call that C. And again, we'll just do A and B as 4 and 5, so that it works out well. So we plug it into the Pythagorean theorem. We've got 4 squared plus 5 squared equals 7 squared. All right, 4 squared is 16. Plus 5 squared is 25, equals 7 squared, which is 49. And then we've got 25 plus 16, which gets us to 41. Right? Okay. 41 equals 49. Now, obviously, this is a false statement. 41 does not equal 49, which means that these 3 side lengths cannot form a right triangle. You cannot draw a right triangle that will have side lengths 4, 5, and then 7 to make the hypotenuse. All right, we'll do one more example just to try this out a little more. We've got 6, 8, and 10. 10 is obviously our biggest side length, so we'll call that C. And again, we'll do A and B for the other 2, just like that. A squared would be 6 squared. B squared would be 8 squared equals 10 squared. All right, and then 6 squared is 36, plus 8 squared is 64, equals 10 squared, which is 100, and 36 plus 64 gives us 100, equals 100. It's a true statement, which means that you can, in fact, form a right triangle with side lengths 6, 8, and 10.